Hello students, myself is Parminder Singh from Prab Kirpa classes. Our today's topic is exploring frequency distribution tables part 2. In one of our earlier courses titled statistics, we had learnt that data is of two types. First is primary data and the second is secondary data. Primary data is the original data which we have collected ourselves, and for the purpose of collection we may have used surveys, interviews, observations, etc. On the other hand, the secondary data is the data which has been collected by the other persons and is now available for use, and this secondary data can be sourced from government record, newspapers, magazines, books, or the data which is available on the internet. After collecting the data, we have to present this data so that the same can be used for the purpose of analysis and to arrive at certain decisions. There are many ways of presenting the data, and one of the forms is to present the data in the form of frequency distribution tables. After going through this course, the students will understand how to make a grouped frequency distribution table where the data in respect of concentration of sulfur dioxide in air of a certain city for the last 2 days is given along with class intervals. In this course, we will understand with the help of practical questions and answers that how we can form frequency distribution tables when the data has been provided to us in different circumstances. Then the students will learn how to prepare a frequency distribution table in respect of the data of number of heads occurred when many coins were tossed many times simultaneously. The students will learn to form the frequency distribution table when the data in respect of the value of pi up to many decimal places is given. The students will also learn how to form a group frequency distribution table when the data in respect of many students is given who watched TV programs for different hours in the previous week. We hope you will find this course very easy and you will be able to understand the concept of frequency distribution table in a very easy language. The students will also learn to construct a grouped frequency distribution table where the data in respect of lives of few car batteries is given. Now the question before us is, a study was conducted to find out the concentration of sulfur dioxide in air in parts per million of a certain city. The data obtained for 30 days is as follows: 0.03, 0.08 and so on. Make a grouped frequency distribution table for this data with class intervals as 0.002, 0.04, 0.04 to 0.08 and so on. Now what is the question? The question is this, that a study was conducted to find out the concentration of sulfur dioxide in air in a certain city, and the data of 30 days was collected, and now we have been asked to prepare a grouped frequency distribution table. What it means? That we are to build a table showing the concentration of sulfur dioxide in the air. Now, one option is that we write that on first day it was this, second day it was this, and then the data will become, table will become very long. So here we are to form a grouped frequency distribution table. That is, we will make a group, say up to 0.04, then next up to 0.04. In this way, we are to make small groups, just like 1 to 4, then 4 to 8, then 8 to 12. This one. So while what is the answer? Now we start. Now in this question, it is also written that the class intervals are mentioned. So first of all, we will have to find out that when we are to design the table, up to which point we are to form the table. That is, up to which class interval we are to form the grouped frequency distribution table. So for this purpose, we are to find out what is the minimum value and what is the maximum value in the data. So we will here find out, we see that minimum concentration of sulfur dioxide is equal to minimum concentration. We will find out, here it is written as 0.03. We will find out whether any item is less than 0.03. This is 0.03, 0.02, 0.02, this is 0.01. Anything less than that? No. So we find that the minimum concentration of sulfur dioxide is 0.01. So now we will also find out maximum concentration. Maximum concentration 0.08, more than that 0.09, 0.17, 0.18, 0.20, 0.22, 0.22, not more than that. So maximum concentration is 0.22. So we will have to make the class intervals which cover the maximum concentration up to 0.22. So we will make class intervals as, we first will be, which will be covering 0.01. So we will have to start from 0.00, 0.002, 0.04, 0.042, 0.08, and so on up to the point which covers the 0.22, and that will be 0.22, 0.24, so that this entry of 0.22 is also covered in the frequency table. So now what the data is about? This data is about concentration of sulfur dioxide. So we will start forming the grouped frequency distribution table. So we will write concentration of sulfur dioxide. So we can write sulfur dioxide as SO2 ppm, parts per million. So now we will also have to count this data, that is what the particular entry falls in the particular class interval. So for that purpose we will write tally, and we will have to consolidate all the items which fall in the particular range. So here we will write frequency or number of days for which the concentration of sulfur dioxide was falling in the particular range. So number of days, or we will write it as frequency. So this is the table which we have started forming. It will have 3 columns. So first will be 0.002, 0.04. Next will be from this 0.04 to 0.08. Then it will next will start from 0.08 to 0.12. That is, every class interval will have the gap of 0.04. Next will start from this 0.12 to 0.16. Next will start from 0.16 to 0.20. Next will be 0.20 to 0.24. We will form the table up to 0.24 so that the maximum concentration of sulfur dioxide is covered within this table. So this will be the table. We will also have to make the total for how many days we have counted. So now the first is 0.03. We will find out in which class interval it falls. 0.03 falls in this. We will make the entry of the same. We may add that if a particular item, say it is 0.08, we will not count it in the second class interval. For the we clarified first, make lines we draw so that we may not become confused when we consolidate the data. So now if the entry is 0.08, we will not count it in the second class interval, because as it is the tradition that we do not count the entry here. It will be counted in the next slab. If we count it in the second class interval, then 0.08 is also appearing in the third class interval. So if we count 0.08 here, it will be again counted in the third interval, and it will result into the duplication of data, and our answer will become incorrect. So as a matter of tradition, we count it as in the next slide or next class interval. We here are to count only that entries which are equal to 0.04 to up to 0.08, that is 0.04 to less than 0.08. So first entry we have counted, next is 0.08. 0.08 we will count at here in this class interval. Next it is again 0.08. It is counted here. 0.09. 0.09 is counted in this. 0.04. 0.04 is not to be counted here, it is to be counted here. 0.17. 0.17 falls here. 0.16. 0.16 is to be counted here and not in this class interval as already told. 0.05. 0.05. This is the 0.05. 0.02 here. 0.06, it will fall here. 0.18 will fall here. 0.20 will not be counted here, it will be counted here, because anything which is equal to 0.20 or more than that but up to 0.24 will fall here. 0.11, 0.08, 0.12, 0.13, 0.22, 0.07, 0.08, 0.01, 0.10, 0.06, 0.09, 0.18, 0.11, 0.07, it will be counted here, 0.05, 0.07, 0.01, it will fall here in the first class interval. Now 0.04, 0.04 will be counted here. So now we will count the number of days which fall in the particular class interval. Now we will take the first 0.00 to 0.04. The number of days are 4. In the next class interval, 5 plus 4, these are 9. In the third class interval, 5 plus 4, this is again 9. In the next 0.12 to 0.16, these are 2. In the next, it is 1, 2, 3, 4. And in the next, it is 2. So now we will count the total number of days so that we may arrive at the conclusion that all the entries, that all the data has been accounted for while we have formatted the table. 28 plus 2, 30. So the data in respect of 30 days is given and all these entries are total as 30. So this is the group frequency distribution table which shows that for how many days the concentration of sulfur dioxide fallen within the particular class interval. So this is the grouped frequency table. Now the next is in this question is for how many days was the concentration of sulfur dioxide more than 0.11 parts per million. So we have to find out for how many days the concentration of sulfur dioxide was more than 0.11. More than 0.11. That is, here all the entries are up to, in this class interval, all the entries are up to 0.11, less than 12, but up to 0.11. So all the entries or all the data which from here to here, that is from 0.12 to 0.24, all the entries which come, that is 2 plus 4 plus 2, that is the 8 entries, that the data in respect of 8 days falls in this particular range. So we will here write the our answer for how many days. So our answer will be number of days in which the concentration of sulfur dioxide was more than 0.11 parts per million is equal to 2 plus 4 plus 2, because all these entries fall in the relevant range. 2 plus 4 plus 2, that is 8 days. This is the answer. We have formed the grouped frequency distribution table and also find out the number of days in which the concentration of sulfur dioxide was falling within the particular range which has been asked for in this question. Now the question before us is, three coins were tossed 30 times simultaneously. Each time the number of heads occurring was noted down as follows. The data is given. Prepare a frequency distribution table for the data given above. Though this question appears to be very tough, it is not so. When we will solve the question, you will find out the same. Now, first we understand what the question means. It means that we take three coins and we toss it simultaneously 30 times. That is, suppose we take three coins and for the first time we toss it simultaneously. All the three coins are to be tossed at the same time. And what the result is, we record it as, in the first instance, when the three coins were tossed, the result was 0. That is, the number of heads were 0. Now, when the three coins were tossed simultaneously for the second time, the result was that the head occurred in one case, and same thing going on. And when the coins were tossed for the third time, the result was that the heads occurred two times, and so on. The data has been collected 30 times. And one position for one case may be that we form a table in respect of all the 30 days, and the data will become, or the table will become, very long. But here we will form a frequency distribution table. That is, we will find out for how many days or for how many times the particular entry occurred, for how many days the head was counted as 0, for how many days it was counted at 1, for how many days it was counted as 2, for how many days it was counted as 3. As the number of entries will be become very less. So here what is given? Here the number of heads have been given. So here now we will form the frequency distribution table. So the first head, we will form the columns where we will first write the number of heads. We will have to count the number of heads which occur, which we will not count verbally, we will write each time. Next, we will count the frequency, that is the number of times the head was found 0 or 1. So these are the columns of the table. So number of heads are either 0 or 1 or 2 or 3. Number of heads, that is, no head has been found, only head has been found in the first only one time or twice, or in all the three cases head has been found as. So this is the will be the formation of the frequency distribution table. Now we will also here do total so that we may find out that all the entries have been counted out. So the number of heads, for how many times the number of heads was 0. We will not start from here, because if we count from here 0, then we will again come to this. No, we will take each and every entry one by one. So first is 0. It will be counted in first. Number of heads 0. Number of heads 1. This will be come here. 2. It will be counted here. 2. It will be counted here. 1. it will be counted here. 2, it will be counted here. 3, 1. Here we are counting the number of times the number of heads occurred. 3, 0, 1, 3, 1, 1, 2, again 2, 0, 1, 2, 1, 3, 0, again 0. You will see that when we are counting for the fifth time a particular entry, we are using this so that we may not have to count each time when the entry is 5. 1, 1, 2, 3, 2, 2, and 0. So here we will count 5 plus 1, 6, 5 plus 5, 10, 5 plus 4, 9, 5. If we have not used this line for the fifth time, we will have to count each and every line which we have drawn, which may result into some confusion. So now we will count the frequency so that we may see that we have accounted for all the data. 16, 25, 5, 30. So we have accounted for all the entries, all the data, that is the number of heads. So we have been able to form the frequency distribution table in respect of the number of heads which occurred when the three coins were tossed 30 times simultaneously. So this is the answer before you. You hope you might have find this answer very easy. Now the question before us is the value of pi up to 50 decimal places is given below. Now the question is make a frequency distribution of the digits from 0 to 9 after the decimal point. That is, we are to take into consideration what is written after this decimal point. That is from this point 1 to next. We will count all these entries. We will not take into consideration this 3. So what is given? These are the digits which has been given to us, and we are to make the frequency distribution. So now what is given to us? These are the digits. So now what we are to do? We are to count the same. That is, we will form a column of tally, and then we will have to find out the frequency, that is the number of times the particular digit has appeared in the data. So these will be the columns of our table, frequency distribution table. So what will be the digits? Digits will be this 1, 4, these all. So we will start from 0. 0, 1 is there, 2 is there, Whether 3 is there? Yes, 3 is there. 4 is there? Yes, 4 is also there. 5 is there? Yes, 5 is there. 6 is there? Yes, 6 is there. 7, this. 8, this. 9, then no entry is 10. So all the entries are 0 to 9. So here we will write total, and this is the outer view of the table. So now we will draw lines so that there is no confusion at any stage, and we are able to arrive at the correct answer easily. To avoid any confusion, we draw these lines. By drawing these lines, we'll be forming proper cell so that the relevant entry is put into the relevant column and relevant row. So the next first is 1, where the entry of 1 comes digits in digits, it comes here. Then 4, digit 4 falls here. 1, it falls here. 5 here. 9 here. 2 here. 6, 5, 3, 5, 8, 9. What we are doing? We are counting the number of times a particular digit has appeared in the data. 7, 9, 3, 2, 3, 8, 4, 6, 2, 6, 4, 3, 3. When we are counting for the fifth time a particular digit, we will draw line this so that we may not have to count all the numbers again. 8, 3, 2, 7, 9, 5, 0, 2, 8, again 8. This is for the fifth time. So we have drawn line this line. 4, 1, 9. This is for the fifth time. 7, 1, 6, 9, 3, 9, again 9, 3, 7, 5, This is for the fifth time. So we draw line this. 1. This is for the fifth time. 0. So now we count the frequency of the particular digit, the total of the same. This is 2. Digit 1 appeared 5 times. Digit 2 appeared 5 times. Digit 3 appeared 5 plus 3 8 times. Digit 4 appeared 4 times. Digit 5 appeared 5 times. Digit 6 appeared 4 times. Digit 7 appeared 4 times. Digit 8 appeared 5 times. Digit 9 appeared 8 times. Now we will do total of all the frequencies so that we may find out whether we have accounted for all the digits while making this frequency table. 7, 12, 20, 24, 29, 33, 37, 42 plus 8, 50. So we have now formed the frequency distribution of digits. Now what is the next point in this question? The next point is, what are the most and least frequently occurring digits? That is the digit which appeared most times and which appeared least times. So we come to the table again. So what item has appeared most rarely? That is the minimum times. This is the 2. This is the 0 digit which has appeared only on 2 occasions. And what are those digits which have appeared mostly? 8. This is the maximum. And this digit, that is the digit 9, has also appeared maximum. So what is the question? Most frequently occurring digit. So most frequently occurring digit is 3 and 9. 3 and 9. How many times they have come appeared? 8 times each. 3 and 9, 8 times. So now what is the least frequently occurring digit? Least frequently occurring digit. What is the least frequency occurring digit? That is the digit which appeared very less times, and that is the 0 digit which has appeared only 2 times. So this was the question, what are the most and the least frequently occurring digits, and now we have solved it here, because without seeing this table we would not have been able to give the answer. While when you are appearing in the exam, you are to write this after the table. Hope we have been able to clarify this question in a very simple manner. Now the question before us is, 30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows. That is, the 30 children were asked for how many hours they were watching the TV programs in the previous week. And in respect of all the children, the data has been given. That is, one child says that he watched TV program only for 1 hour. Another says I watched TV for 6 hours. Third says for 2 hours, and so on. Now, make a grouped frequency distribution table for this data. That is in respect of this data. That is the number of hours TV programs were watched. We are to make grouped frequency table for this data, taking class width as 5 and one of the class intervals 5 to 10. So, we will form the grouped frequency distribution table. Now, we will have, for building the grouped frequency distribution table, we will have to find out the minimum number of hours the television was watched or the maximum number of hours. Now we will find the minimum number of hours. We find minimum number of hours as 1. Anything less than 1? No. And we find maximum number of hours as 6, 12, anything more than 12, 15, more than that 17. So the maximum numbers of hours are 17. So we will have to form the grouped frequency distribution table which covers the minimum number of hours as well as the high maximum number of hours. So we make frequency distribution table with class intervals as, here it is written as 5 to 10, but we are also to consider the minimum number of hours starting from 1. So we will start from, here the class width is written as 5. So we will start from 0 to 5. That is the difference between the maximum class, this point or this point is 5. Here the difference between any class interval is also 5. So 5 to 10, 10 to 15 and 15 to 20. We will form the frequency distribution table in which the class intervals are these 4. So we will write here the data which has been given to us is in respect of the number of hours. Number of hours TV watched, television watched. We will have to count the same. So we will form the column of tally. So next we will have to sum up the number of children, that is how many children watch the television for the particular class interval. So here it will be number of children, or we can count it as frequency. These are the 3 columns which we have formed in respect of the frequency. Number of hours TV watched, we have formed the class intervals as 0 to 5. That is for all the children who have watched the television for from 0 to up to 5. That is less than 5, but not 5. Next class interval is 5 to 10. So any children any child who has watched the television, so say for 5 hours, will fall in the class interval this range 5 to 10, and not in this. If we take the child which has watched television for 5 hours in the first class interval, then it will result into duplication, because 5 is written here and 5 is also written here. But as a matter of convention, we will take the entry of 5 in the second class interval. In the same way, if any child has watched television for 10 hours, it will be taken in this third class interval. Next is 15 to 20. So these are the 4 rows of the number of hours television was watched by the children. So this is the first child who has seen the television for 1 hour. It will fall here. Another has watched for 6 hours. It will be counted here. 2. It will be counted here. 3. It will be counted here. 5 hours. 5 hours will be counted here and not here as a matter of convention. 12. It will be counted here. 5. 8. 4. 8. 8 hours. When we are counting any data for the fifth time, we will use this line so that we need not to count the tally. 10, 3, 4, 12, 2, 8, 15. 15 will be counted here and not here, as already told, as a matter of convention. 1, 17, 6, 3, 2. As this is for the fifth time, we will use this line. 8, 5, 9, 6, 8, 7, 14, and 12. So now we will count the number of entries which fall in the particular class interval. So the number of children who watch television in between 0 to 5 hours, they are 5 plus 5, 10. The number of children who watch television for 5 to 10 hours, that is less 5 to less than 10 hours, are 13. 5 plus 5 plus 3. Another are who watched television from 10 to up to 15, that is less than 15, they are 5, and 15 to 20 are 2. We make the total of the same 23, 28 to 30. So the data has been given in respect of 30 children. So from this table, it is clear that we have accounted for all the children while preparing this frequency distribution table. So this is the grouped frequency distribution table which is before you. Now the next part of the question is, how many children have watched television for 15 or more hours a week? 15 or more hours a week. As already told that when we are saying about 15, 15 will not be counted here. As a matter of convention, 15 is counted in the next, where it is the lower class limit. This is the upper class limit. So when we are talking about the particular class limit, we will take it as lower class limit. 15 is the lower class limit here. So all the entries where the television has been watched for 15 hours or more than that, it will be counted here. So the answer for us is 2 children. So we will write that 2 children have watched television for 15 or more hours a week. We hope we have been able to explain you this question regarding the viewing of TV programs by some children in the past week in a very simple language. Now the question before us is, a company manufactures car batteries of a particular type. The lives in years of 40 such batteries were recorded as follows. Construct a group frequency distribution table for this data using class intervals of size 0.5 starting from interval 2.25. So now what is given to us? That a particular company, that there is a company which manufactures the car battery, and he has recorded the data in respect of 40 such batteries for how many years the particular battery performed. So what is the data is about? The data is about the lives in number of years of the batteries. So now we will have to construct a frequency distribution table which is in grouped form. So here we will have to find out the minimum value of the data, that is the minimum value in years for which a particular battery might have performed. So we see that minimum is minimum value in years is minimum value is 2.6, 2.6, 2.6, 2.2, 2.2. Anything less than that, no, no battery has the life less than 2.2. So now we will also find out what is the maximum life of any battery which was recorded. Maximum life is 3.7, anything 4.1, 4.5, 4.6, anything more than that. No, there is no battery which was having life more than 4.6. So we have taken these two entries, that is the minimum value in years and the maximum value which was recorded was 4.6, so that we may make the grouped frequency distribution table keeping in view both these items. That is, both these items, both these data should be covered in the grouped frequency distribution table. What the data is about? This is the data about lives of batteries in years. As we will have to count the number of batteries, we make the column of tally. So as we will have to sum up the same tally, we will write here the number of batteries So we have formed these three columns. So these are the columns. So now we will form the class intervals starting from 2 to 2.5. 2 to 2.5. Now the class intervals are 0.5. So now the next class interval will start from 2.5 to 3. The next will start from 3 and it will go up to 3.5. Next will be 3.5 to 4.0. And the next will be 4.0 to 4.5. And the next will be 4.5 to 5, as we will have to take into account 4.6. So here we will draw the lines so that there is no confusion at any stage when we count the number of batteries which fall in the particular class interval. So here we have formed the overview of the grouped frequency table. Now we will here count the life of the batteries. Next, first is 2.6. That is, the one battery was having the life of 2.6 years. So it will be coming in this class interval. 2.6 will come here. It is to be added that if, say, one battery is having the life of 3 years, it will fall in the third class interval, that is here, as a matter of convention. If, say, any battery is having the life of, say, 4 years, it will not be counted here. It will be counted in this class interval 4 to 4.5 as a matter of convention. Because if we count the life of 4 years here, it will be resulted into duplication because the 4 is appearing 2 times. It has been mentioned 2 times as a matter of continuity. In any particular class range, we will take it as, for example, 2 to 2.5 means anything which is having the life of 2 years but up to 2.5, that is less than 2.5. In the same way, any battery which is having the life of 2.5 and more than that but up to 3, but that is less than 3, when the battery life comes 3, it will be counted in the next. So in this way we have to make the entries. So here the next battery is having the life of 3 years, it will be counted here. Next 3.7, it comes here. 3.2. Once the concept is clear to you, there is no problem for you to make the frequency distribution table. That is where you are to put the relevant data. Next is 2.2, 4.1, 3.5, 4.5. Here we have counted 4.5 here and not here. 3.5, 2.3, 3.2, 3.4. When we are counting the entries, suppose two entries are having the same value, we will have, do not cut twice at the same time. We will have to use cutting one entry at a one time to avoid any duplication or confusion. 3.8, 3.2. When we were writing any entry for the fifth time, we will use this line so that we may not have to count the any items again and again. so that series we can save the time while solving the questions. 4.6, 3.7, this is for the fifth time, 2.5, 4.4, 3.4, 3.3, 2.9, 3, 4.3, 2.8, 3.5, 3.2, 3.9, 3.2, 3.2 will fall here and it is for the fifth time. 3.2, 3.1, 3.7, 3.4, 4.6, 3.8, 3.2, 2.6, it is for the fifth time. 3.5, it is again for the fifth time. 4.2, 2.9, and 3.6. So now we will count the number of batteries which are having the life of batteries in the falling in the particular class interval. So now we will count the number of batteries which are having the life in between 2 to 2.5 years. These are 2. Next is the number of batteries which are having life of 2.5 to 3 years are 5 plus 1, 6. Now the next is the number of batteries having life in between 3 to 3.5. These are 5, 5 plus 4. 10 plus 4, 14. Now the next are the batteries which are having life 3.5 to 4 years. These are 5, 5, 5, 10 plus 1, 11. 4.0 to 4.5, these are 4. Next is the number of batteries having life in between 4.5 up to 5 years. These are 1, 2, 3, 3. So now we will count the total number of batteries which we have recorded in this data: 2, 6, 8, 22, 33, 37, and 3, 40. So it means that we have accounted for all the 40 batteries in our record. So we have been able to construct a group frequency table in respect of 40 batteries where they were having the life in years and the data for the same was provided to us. We hope we have been able to clarify this question in a very simple language, though all these questions which pertain to the frequency distribution table take some time in solving the same. You are not to get puzzled or go through hurriedly, because if we go through hurriedly in solving the questions, there may be some confusion, or we will have to again attempt to solve the question because there may be some confusion or some error while solving the question. So we will have to solve these types of questions very patiently. Thanks for watching. If you like our course, please spare some time to give star rating to our course.